represent the Reynolds number. So our group members consist of 13 person, and the leader is Muhammad Taufik, second Anis, third Al-Not, fourth Muhammad Iman Rifat, fifth Ahmad Syamil, sixth Afif, seven Iqmal, eight myself Muhammad Anwar, nine Muhammad Nur Iman Syafaat, 10 Siti Khairina, 11 Siti Nur Akila, 12 Zahira, and 13 Nur Afika. So today I will share the story of Reynolds number. Reynolds, or his original name was Reynolds, born in 1883 at British, and he was engineer and physics during his time. He was demonstrate the transition from laminar to tubular flow in pipe using formula. The formula that he created, known as Reynolds number, and is applied to various type of flow that involve with fluid. That's all.
Hello, Assalamualaikum. Today I'm going to be explaining about Reynolds number. Reynolds number is ratio of initial force to viscous force. It is parameter to predict if the flow will be laminar or turbulent. When the viscous force is dominant, the flow will be laminar, and the initial force dominate, it will be turbulent. And increasing in Reynolds number indicate an increasing in turbulence of flow. As you can see here, the laminar flow is a smooth flow, and the turbulent flow is uneven flow. It is also can be defined as Reynolds equals to rho dD over mu. Thank you.
Hello, my name is Ahmad Syamil bin Nur Rizwan. Today, I'm going to explain about the Reynolds number regimes. It consists of two parts, which is laminar flow and turbulent flow. Alright, let's proceed to the first one, which is laminar flow. Laminar flow tends to occur at lower flow rates through smaller pipes. In a sense, the fluid particle flow in cylinder. In a simple word, laminar flow is a well-ordered pattern of flow whereby fluid layers are assumed to slide over another. Alright, let's go to the next one, which is turbulent flow. Turbulent flow is by nature chaotic. The fluid mixes irregularly during turbulent flow. It produces constant changes in the flow's behavior. Or in the simple word, turbulent flow is irregular flow, fluctuating velocities.
Okay, hello, my name is Anol. So as you can see here, today I'm going to be talking about the identification of Reynolds number. So Reynolds number is to identify the type of flow of a fluid. So as you can see here, this is the formula for the Reynolds number, which is Reynolds number equal to rho times volume times diameter and over mu, which is rho is the density of fluid, and V is the velocity of fluid, and the D is diameter of pipe, and mu is the dynamic viscosity of fluid. So in this condition, as you can see, this is the condition, which means it consists of three types of condition, the types of flow. So if the Reynolds number is greater than 4000, it means the flow is a turbulent flow, and if it's lower than 2300, the flow is a laminar flow, and if it's between the 2300 and 4000, it means the flow is in the critical flow. That's all from me. Thank you.
An engineer requires to design a pipe to discharge the flow into the drain. The flow must in the laminar flow. To get that laminar flow, we have to have the length of the pipe, diameter of the pipe, type of fluid, and the time taken for the fluid to discharge. So the solution is the engineer needs to put in any suitable diameter and length of the pipe in order to get the laminar flow. So they have to calculate the Reynolds number. When the Reynolds number has been calculated, they now can identify the type of the fluid flow.
Hi, my name is Afia Hafizan. I represent interface. On top of our interface, we put our problem statement. We divided to three sections, which is input section, Reynolds number section, and velocity section. Next, our properties of the form and each control. For example, we have form control. frame control, label control, option control, and command control. Next, inputs. There are 3 boxes where the user need to key in the desired length in meter, time in second, and the diameter in mm. The option button is where the user choose one of the fluids which have its own diameter, viscosity value, and one of time given. Processing section. Processing section, we have 4 command buttons, which is calculate velocity, calculate Reynolds number, clear inputs, and exit. For output, we have there are 2 output boxes which display the value of velocity and the value of Reynolds number. To view the velocity output, the user need to click calculate velocity box, while to view the Reynolds number display, the user need to click calculate Reynolds number box. That's all from me, thank you.
In programming, a declaration is a statement that describes an identifier such as name of a variable or a function. Declarations are important because they inform the compiler or interpreter what the identifying word means and how the identified thing should be used. So here we declared a few variables such as the inputs and outputs. Inputs such as length, diameter, time, density, and velocity, while the outputs were velocity and the Reynolds number. We also declared the constant VB key minus equals to 45 and constant VB key dec PT equals to 46 to make sure that during the input, the VB ASCII keys can be activated, so no other numerical values can be entered except for backspace and decimal numbers.
Hello guys, so this is part for calculate the Reynolds numbers. As you can see, this is the code for calculate the numbers. There's the formulas, density, velocity, and diameter, and so on. This we can see the command button here. We press it, calculate the Reynolds numbers, and this is the output shown here. This is the example. As when we get the result of the Reynolds numbers, if the Reynolds numbers is above 4000, it is a turbulent flow. But if it is below 2300, it will show the laminar flow.
So in order to determine the velocity by using the value of length and time, we can easily calculate the value of velocity by using this formula, which is length over time, and then we click at this common calculate velocity, and then it will process the output. So it will appear in this box, and then it will come out as an output. It will be shown like this.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anis bin Samsudin. Now I would like to explain about clear command button. When this button is clicked, then all of the inputs that have been added will be reset and cleared. For this clearing section, the coding interface is set as common clear. When you double click this command button, there will be a coding section for it. For example, private sub common clear underscore click bracket. Set all values back to 0. For the diameter, txt diameter dot text equal apostrophe. Same for the length and time. For the velocity and RE, label velocity dot caption equal apostrophe and sub. That's all for me, thank you.
Next is exit section. The coding for exit section is private sub cmd exit underscore click and sub. When the exit button is clicked, the current loaded form should be exited. This means that when you click the exit button, you are exited for the calculation of Reynolds number and viscosity.
Assalamualaikum and hello guys, I am Iman Rifat. Okay, for now, I will explain to all of you about the crucial part in this coding section, which is the input section of length and time. Okay, first of all, for the input section of length. So as we know that velocity is equal to length over time, so we need to input a certain key or value to the input of length and also time. So when we double click the input section, the text box of length, so it will become a private sub txt length underscore key press, bracket key press, key sc as integer. It will only allow number keys, minus sign, decimal point, and also the backspace. If bracket the key sc greater or and equal to VB key 0 and key sc less or equal to VB key 9 or key sc equal to VB key minus or key sc equal to VB key that PT or the key sc equal to VB key back, and then it will become exit sub, or else the key sc will become to 0 and B become the end if and the end sub. So for the next, for the time instead, txt time underscore key press, key sc as integer, only allow number keys, minus sign, decimal point, also integer. So if bracket key sc greater equal VB key 0 and key sc less than VB key 9, or the key sc equal to VB key minus, or key sc equal to VB key that PT, or key sc equal to VB key back, and then it will become exit sub. Or else the key sc become to 0, it will be bit, and if, and sub. That's all from me. Thank you.
Hi guys, Assalamualaikum warahmatullahi wabarakatuh. My name is Taufik. Today I'm going to show you guys how this program going to work. Okay, we can proceed to the program. Okay, first we need to open the program. Alright, from the interface here, we need to put the value for the diameter in millimeter, length in meter, time in second. For next box, we need to put the type of the fluid, which we got water, glycerin, ethyl alcohol, and seawater. And after you click this button, calculate velocity, the value of the velocity will be shown here. And if you press this button, the value for the Reynolds number will be shown here. Okay, I'm going to show you guys how this program going to work. First, for the diameter value, I put 10. For the length, I also put 10. Time, also 10. Okay, for the type of the fluid, I just gonna go with the glycerin. Okay, click calculate velocity button, and we're gonna get the value for the velocity is 0.1 meter per second. Okay, next for the Reynolds number, we're gonna get the value is 1.31, which is the fluid is laminar flow, which means you can use this pipe. Okay, next I'm gonna clear these boxes, and I'm gonna put 99999 for diameter. For the length, I'm also going to put 9999999. Time, also 99999. Okay, for the type of the fluid, I'm going to use seawater this time. Okay, calculate the velocity. We got 100.00099. For the Reynolds number, we got 10000901751.66, which means our fluid is a turbulent flow and we cannot use this pipe. Okay, that's all from me today. Thank you so much. Bye bye.